And welcome back. As we go ahead and continue to look at C++, let's go ahead now and examine how variables, function, and scope all tie together. So when we start talking about the scope of variables, one thing you have to understand, in C++, there's four primary kind of categories for variable scope. You have local variables, you have global variables, you have static local variables, and you have thread local storage variables. With local variables, these are variables that are defined typically inside of a function. All right, that's very much what we're used to from other languages, Java and stuff like that. So these are local variables. Their scope is limited to whatever function or method, if you will, that they've been defined inside of. In simple terms, the local variable exists and can only be accessed inside of that particular function. Once you move outside the function, you no longer have access to that variable. Then we have global variables. Global variables are variables that are defined outside of every function, and it's known as a global variable because the scope of it is the entire program. In other words, if I were to have, as we will see here, other variables that exist outside of that immediate scope, I can access them, and they're not necessarily limited to one particular object within that program. Another thing with global variables, it means that they can be used and changed at any part of the program after the initial declaration. Then we have static local variables. Now you'll notice, of course, we have the keyword static here, which is specifying that we are, of course, using a static variable. A static local variable exists only inside of a function where it's declared, just like a local variable would be. However, its lifetime starts when the function is called and only ends when your program ends. So the main difference, therefore, between a local variable and a static variable is the value of the static variable is going to persist until the end of your program. So once you have, it's not going to pretty much exist until that function is called. Once it's called, though, it will then persist throughout. And lastly, we have thread local storage. Thread local storage is a mechanism by which variables are allocated. There's one instance of the variable per extended thread. Now the keyword thread local is used for this purpose. For our learning purposes, though, we're going to avoid using thread local storage because we're not dealing with anything with threading. So for our purposes, this is just a kind of little footnote to know, like, oh, these exist. Instead, the two things we probably want to focus on will be local variables and global variables, as we can see here in this demonstration in Visual Studio. You can see I have a global variable. I've called it int global x, and I've set it to 15, and then have a local variable here inside of this function called add to x that's identified as local x. So if you look here in my main function, I can call this function add to x, and of course I can then use it. Now, if I run this program, all right, we get the original value of the global variable is 15, enter integer to be added. I'm going to type 5, we get 20. Now, what does that mean? That means that it took and added it in. However, if I try to do things like down here, I'm going to say global x is equal to 10. All right, notice I can access the variable. I can change the value of it. It is not unrestricted. It just simply exists outside of the scope of everything here. But if I try to use local x and I assign it a value, you'll notice we get an error here because, again, local x exists only inside of this function right here. This int main function, which is, of course, the main block that we're used to working with, does not have local x identified, so it can't actually use it because, again, local x is a local variable. Whereas global x, we can go ahead and manipulate and use because it is a global variable in its scope. So just a quick demonstration of how we can use some of these things. Obviously, you might be able to look at this and say, oh, there are going to be certain advantages and disadvantages. And there are times, of course, when we want to restrict variables in their scope because if we made everything global, then everything and anything could access those variables. So there are going to be times when we want to make sure our variables are much more restricted because we don't want them to be outside around. Think about like when we talk about like private and public modifiers, for example, same kind of idea. We want to restrict the access to those either variables or methods or even functions to kind of keep them from being used in instances we don't want them to.